It's that time of year again when a number of us in the robotics community are working on the final stages of conference paper submissions to a conference like ICRA. I've just run through a typical structure of what a typical ICRA paper would look like with my research group, and I thought I'd share some of the key elements of that in a short video. I've got my sketch here with all of the various structural elements, and I'll pop these up on the screen as I go through them. I'm assuming at this stage that you've got a pretty much complete paper, you're working towards a complete paper, you're not sort of hugely uncertain about the results. I have done other videos in the past on how to ideate and how to come up with good research ideas that are suitable for a paper. This is more about what you would expect in the typical structure and layout of a paper. I've authored or co-authored, I think, over 50 ICRA and IRIS papers in my career, or more than that. I'm not exactly sure what the count is. And you will go back, if you go back through those, you will find me breaking a number of the rules. In this video, this is, I guess, general advice. There are always exceptions, and you don't have to do all of these things to come up with a compelling paper. The first thing to consider with regards to the structure of the paper is the overall length and what is counted in that length. A typical format for a paper like an ICRA paper might be that you have 6 pages in double column format to write the main body of the paper, and then you have an arbitrary or nearly unlimited number of pages beyond that to put references into. The nice idea of this unlimited or nearly unlimited reference approach is you're not conflicted in terms of spending space on what you want to present and spending space acknowledging all of the great research that you're building on. The front page is vitally important for a conference paper of this type, especially a short conference paper where there's only 6 pages. At the top, you have your title. Title is something that's worth spending a lot of time on because you want to be as economical and specific with the words you put in your title. Try to avoid general fuzzy words or weasel words. If you say that your system is efficient, what do you actually mean? Is it capable of online or real-time operation? Is it capable of very good scaling computationally? Does it have linear or sublinear scaling? Is it capable of deploying on a specific target set of hardware? What is the specific contributions or claims or benefits of the research you're going to present in the paper? Make sure that every word, adjective, verb in the title is actually really critical to get the point across and trim any that don't need to be there. If you like acronyms, there are lots of acronyms formed for computer science papers, including in robotics. Just make sure you don't get too cutesy with your acronyms. You always run the risk of annoying your reviewers if your acronym is like a clear butchering of the actual words in the title or the system you're proposing. Below the title, you'll often find the abstract. The abstract is a long form, typically single paragraph that captures the overall story, context, relevance, and significance of the research that you're presenting in the paper. You might have a sentence introducing the problem domain or the set of methodologies or techniques that you are building or improving upon. You might talk briefly about the key details that are inherent to your technique. Talk about how you evaluated the system or how you demonstrate or provide evidence that it's better, like the experimental approach, the sort of results that you got, which are hopefully meaningfully improved or better in some way, and then perhaps relate it back to the overall context of where this work occurs and is placed in the broader robotics or whatever discipline field you're in. Depending on the conference paper format, you may also list keywords below the abstract or somewhere on the first page. Alternatively, they just may be entered directly into the online system. The rest of the front page is typically taken up by a section called the introduction section. A typical 6-page robotics conference paper plus references, you would aim to get the introduction all wrapped up and done entirely on the first page. Sometimes it might be a bit shorter than that, sometimes it might spill over onto the second page, but that would be a good rule of thumb to aim for. In the introduction, there are typically two ways you can go in terms of contextualizing the research. One is to introduce the problem domain that the research you're presenting occurs in. So the problem domain may be agile drone flight, it may be autonomous vehicle localization, it may be human-robot interaction in a surgical theatre. So that's providing context in terms of the eventual application domain that you hope your research will make a difference in. The other approach here is if you are building on a set of neural network architectures or techniques or approaches and improving them in some way. And so you would motivate it by talking about the typical methodology or techniques used in a certain area of robotics and how you are improving on those. You can do a combination of both. In that second case, you would still want to contextualize what the relevance of improving these techniques might be. For example, reducing the amount of training data or the amount of compute needed for some of these complex neural network-based approaches in robotics, which is obviously relevant where robots have constrained compute and constrained cost. You will need to motivate why there is the need for the work that you presented in or are presenting in this paper. It's important here to not be unnecessarily critical of past work. You can talk about what past work has achieved and the various benchmarks it's set, while also highlighting that more work needs to be done before that work becomes entirely useful, for example, in a particular application domain. So this is something that takes a little while to get good at, but combining a constructive, positive tone and portrayal of what has happened before with a clear identification of the things that still need to be done, hopefully which you are at least partially addressing with the work in this paper. Introductions would also typically have one or two other components. One of them might be a list of key contributions that you are claiming in the paper. So it could be one or two bullet points, for example, about the key innovations in the methodology or techniques that you're presenting in the paper. Perhaps you are contributing a new substantial set of open source code contributions that could be useful to the community. Perhaps you have curated a new data set or set up a new robotic benchmark testing platform that is now available to the community. Those would all be potentially classifiable as contributions. If your research is building heavily on work that you've previously done and published, or that another researcher has previously done and published, another thing you might consider putting in your introductory section is something that clearly differentiates or points out what you have done in this work that is new or in addition to what has previously been done. Basically convincing the reader that this paper by itself presents enough additional contributions over the similar work that has been done before. Two other things to consider for that front page introduction section. One is the FPF, the front page figure. Often papers are helped immensely if you can come up with a figure on the front page that does ideally three things. One is that it visually illustrates the core problem or limitation that you're addressing. Secondly, it shows, at least at an abstract level, the key innovation or key the key methodology of how your approach solves that problem. And third, shows, at least in schematic form, how that results in better performance or more useful performance, something that is beneficial over the previous state of the art. Combining those all into a single figure without making that figure really, really noisy and unnecessarily complicated is an art, but it's a very worthwhile investment because once you get there, you will reuse that figure endlessly in your presentations and in lots of other materials, and it can really sell or get the paper off to a great start on that front page. Finally, at the end of the introduction, and this is optional, not everyone does it, you might very succinctly lay out the rest of the paper. So describe very briefly what the other sections are in the paper and what you're going to cover in each of these sections to give the reader some sort of expectation of what is to come in the remaining pages. When you get onto the second page, you'll typically start entering your background section. In the background section, you are talking about all the great work that is relevant or broadly relevant to what you're proposing or presenting in this paper. I have been taught by my previous supervisors to start each of the major sections in your paper with what we call glue. This is like a couple of sentences that remind people what the section is about, why we're presenting what's in the section, and why the reader should care, basically providing the reader with some guidance and explicit navigation about what they're just about to read and why it's important. You would typically organize your background section with subheadings. Often, based on the research you're doing, there are 2 to 4 relevant sub-areas of previous research that you might present, and they would naturally lend themselves into subheading sections where each subheading might have one paragraph with references in it that addresses that particular background. If you're in a very popular field with lots of people working on it, your related work review will all be very closely aligned to work that is very similar to what you're proposing. If you're working in a new or smaller field, you will often have to go a little further afield in terms of finding conceptually relevant research to talk about in order to contextualize what you're doing. As you go through the background coverage, once again, that not being unnecessarily critical, you are representing objectively what others have done before, but you are also hinting at some of the shortcomings of those previous methods. Here the key, because you have limited space, is to primarily focus on the shortcomings that you are presenting a solution to. This is not a 50-page general survey paper. You don't have the luxury of talking about all of the limitations, so focus on the ones that are most directly relevant to the solution that you are presenting. You can hint at these limitations throughout the background section, but then you might consider at the end of the background section a brief couple of sentences that recap what you've presented, what the bulk of the field has done before you, and what the key 1 or 2 limitations are that you are specifically addressing in the work that is to be presented in the rest of the paper. After the background section comes the approach or methodology section. This is often one of the largest sections of the paper, and this is where you present the key elements and technical details of your approach. If this is a heavily theoretical paper, you may have a lot of theorems or derivations in it. If it's a more practical algorithmic type paper, you may present actual equations or pseudocode that describe how to implement your approach. Once again, suggest starting the section with some glue, some overview, tell people what you're going to tell them about in the section and why it's important to understanding the overall context of the research you're presenting, and talk about the various subheadings that you will typically use that break down each of the components of your methodological contributions. Sometimes you need to include standard methodological descriptions in your approach and methodology to make the work self-contained, to minimize the amount of cross-referencing and reading of other papers that people have to do, to help your reader, especially your reviewer, understand how to evaluate the paper. Make sure you make it clear that some of the work that you're presenting in the methodology is just presented in order to provide the foundation which you build upon, and then highlight the parts of the methodology that are the new things or the contributions that you are claiming. Just so your reader or reviewer doesn't get the wrong idea that you're claiming that everything you're presenting, including some of the basic essentials, is all novel work that you've come up with yourself. After the approach or methodology section, typically comes the experimental setup section. People who are new to writing papers sometimes get a little bit challenged by what should go in the methodology section and what should go in the experimental setup section. The experimental setup section typically focuses on how you tested and evaluated and assessed the contributions that you're proposing in the paper. So you might talk about the data sets that you processed or the robot platforms that you ran your system on, whether it's a drone or an autonomous vehicle. You might talk about the metrics that you use to assess the performance of your system. Often, assessment involves comparison to the previous state-of-the-art system, so you might talk about what previous state-of-the-art systems you chose and why you think they are representative of a baseline in the field. You might also talk about how you chose the parameter values for your system. Often you might have a table of specific parameter values in the experimental setup section. This helps people who follow on your work replicate your work because they know what specific values to plug into the system. As well as putting the parameter values in, you should at least explain how you came about those parameter values, even if it's something like you tested on a lot of sort of data and came up heuristically with the parameter values that seem to work the best. Tell people that, because that's still better than leaving people in the dark and not giving them any insight into how you came up with these values, because they will have to do the same thing for their circumstances. At the end of the experimental setup section, you could also potentially put a footnote which links to a URL that links to datasets or open source code that you are providing. Make sure that this doesn't violate any of the double-blind requirements if the conference has a double-blind type requirement, but often your contributions would be footnoted there. After the experimental setup section, you would typically have the results section. So this is where you show what your system can do and perhaps compare it to previous state of the art systems. Once again, suggest starting with a little bit of glue, a little bit of an overview that highlights the various subsections and the various types of results that the reader is going to be looking at. The actual division of the results section typically has 1, 2, or 3 different components. I always suggest that you lead off in the results section with the flagship quantitative results for your system if they are available. So when you put everything together in your system and it's working at its optimal point, how does it perform and perhaps with a fair comparison to some of the state-of-the-art previous system. So go in strong, showcase the key capabilities of your system. The second part of the results you might consider is the part where you do analysis, you do ablation studies, you do parameter sweeps, you show how sensitive your system is to various parameters, you analyze perhaps the compute profile of your system in different scenarios, you help the reader gain deeper insights into why the system is working, why the system sometimes fails as well. It's important to show failure cases for a sort of representative portrayal of what you're doing, and other things that help the reader just understand what you've done and why it works. Finally, if you are doing experiments on robot platforms, you might have robot demonstrations. So this is where you show that your system, for example, a localization system or a terrain traversability system, helps your robot move or navigate or interact with the real world in some manner that is useful. Sometimes this is a once-off demo. It's not like 100 trials. It's just showing that in principle this system works. In other cases, you might run extensive trials on the actual robot platforms, and that will actually be the primary result. After the results section, you have a few options. I like to end the paper with a discussion section. Some people like a discussion and a conclusion section, or just a conclusion section. You don't have a lot of space in a typical conference paper, so I do like just picking a single section, which is discussion. What goes into the discussion, you might consider a very brief recap of what has come up in the paper to this point, just to provide context. You don't want to spend more than a few sentences doing this. You've already made the case by this time in the paper, or you haven't managed to convince the reader, so you're not going to get them over the line here. In the discussion section, you might talk about all the areas or some of the areas that are most exciting or most promising for future work. Your work will have solved some problems, and it will have also identified new problems or new challenges or new opportunities to pursue. And so this would be a logical place to discuss some of those. Be careful to put anything too trivial in this section. If you put something in here that you should have done in the actual paper as it's presented now, you might tempt a reviewer to tell you to go back and do that rather than accept the paper. So make sure you do all the little things rather than putting them in the future work, and make sure that the future work suggestions are more substantive pieces of work where possible. After the discussion section comes the references, often not counted in the official page count. This is where you have the chance to acknowledge and reference the key relevant prior work that has come before yours, and it's important to try and get as much coverage of what has come before you. Don't just necessarily look at the last year's worth of work, although that is tempting in fast-moving fields. Do make an attempt to go back earlier in the field, because typically, especially in big fields, there has been pioneering work that goes back a lot further in time. Once you've got the complete near polished or fairly polished final draft of your paper, one of the most valuable things you can do is go back through that paper and sentence by sentence, starting at the title, verbally to yourself explain what the purpose and role of that sentence is. You should be able to do that for every single sentence in your paper. For example, one sentence might be, this sentence establishes that these techniques have not yet been ready for game time. The real world does not have robots using these techniques yet. Another sentence's purpose could be to signal very clearly to the reader that the system you're proposing is not claimed to be a complete fix to everything. You are instead sort of talking about the nuances of what specifically your system does and doesn't solve. Another sentence could be flagging that you know that a lot of similar work has been done in a totally different discipline, and that you are aware of this work, and that you can explain the specific challenges in translating that work directly from that other discipline into your discipline. Every sentence in your paper should have a clear purpose, often just a single purpose, and going through the paper sentence by sentence near to submission time and checking that every sentence needs to be there and checking whether there are any missing sentences is one of the most useful things you can do to get that final improvement in quality and contribution of your paper. Another key thing you can do is doing the does it need to be here on a word by word basis. You need to be very careful that you don't use too many superlatives, adjectives, adverbs, unless they're critically needed. So if you say the performance is good, what do you actually mean? The more you can be specific about what your claim is, the clearer the paper will be. The more you can minimize generic words that don't actually have any real meaning, the crisper and more concise your paper will be, as well as the messaging. So be very careful of using too many of these unnecessary words. That wraps up this video talking about sort of the key structure of what is in a current robotics conference paper. This is just a small fraction of the tips. As I mentioned before, I have other videos on how you come up with the ideas and shape the ideas for the paper. This video has really been about that structure and what you might expect in a typical paper. Writing a paper isn't just about writing the paper so it gets submitted. As you write and refine and edit the paper, you do think deeply about the nature of the research that you've done, and the writing process is often a fantastic way to think about what you might do next, what were some of the shortcomings or limitations or things you may have missed in the research to date. And so it's important to consider the act of writing a paper not just about getting that paper submitted and hopefully accepted, but as an actual constructive part of the larger research process. Happy paper writing.